So these are directly from Delta Math. So you guys, please type in questions, make notes. I won't probably work every one of them because, again, I want to be as close to respectful of your time as possible. And I know we went over the last couple of times we've gotten together, and I try not to do that very often if we can help it. All right, so combining like terms, we did this when we went over, because most of you guys were there when we went over the solving equations from the first week. But so like 10f is the same as the negative 5f. Then our constant, because there's no variable, negative 5, and then plus 2. So you're going to put those things together. So a positive 10f means you have $10. And then that minus 5 or negative 5f means you lost 5. So that means you should have 5f left. Then our negative 5 and our positive 2, that means we lost 5. So we owed somebody $5. We paid them 2. Then that means we still owe them 3. And that would be the combining of like terms for that guy. I would say that the ones that popped up for the most part were pretty straightforward. The one prior to this where they are this straightforward, you're just sliding like the negative 5f over on top of the 10f, and then you're answering that one, and then you're sliding over if there's another f, and then you answer that one, and they just take it one step at a time. Yeah, Logan, we switched into algebra now. We're done with statistics. So then we have a negative 4t. That negative t, one thing I do tell a lot of students, and it seems simple, is whenever you start a problem, especially if you can write it down on a piece of paper, put a 1 in front of it. It seems really ridiculous, but it'll keep you from forgetting that it's there. Though if I ask you one-on-one and I get your attention, like what number is in front of a t if there's no number present, most of you can tell me one, but when you're starting to do your math and go through your problems quickly, then we forget or just lose it. And then instead of doing anything crazy, this is a negative 5t, and that's a question mark if you can see it because I couldn't get close enough to the 5t. So all three of those are like terms. So I owed somebody 4, that negative 4. I paid them positive 1, so now I owe them a negative 3. And then I borrowed 5 more. So it would be negative 3t minus 5t. Like if you're doing the very first portion of your delta math, this would be sort of how you're doing it. Then you would slide these together, and that's going to give me a negative 8t. So we owe somebody at this point 8 still. We're in the whole 8. Those are the only ones of those that I pulled because I feel like for most of you, and those of you who show up to class usually are the ones who know kind of what's going on. If you need more of that, like just basic examples, just shoot me a text or an email and I'll send it to you in the next little bit. There's also an ed puzzle posted for today on the basics of combining like terms, but it should be something you've been doing for a couple years prior. But obviously with COVID and virtual learning, I don't know what teachers have gotten through and what they haven't gotten through. So if you need more, it's just a matter of telling me. Now the next 3, I love these questions because it is a really basic skill. And like I've told you before for Math 1 EOC, they take the basic skills you've been doing forever and they spin them up into these magical, fun, like weird ways to ask it. So a triangle, and I'm going to over-explain probably for the first one. So ideally, I would draw a triangle if I had no idea what I was doing first, just as I was reading. Has side lengths of 2b plus c, 7b plus 4d, and 6d plus 2c. Which expression represents the perimeter in centimeters of the triangle? So on delta, it's a multiple choice. But perimeter, remember perimeter means if I walk all the way around it, so this side plus this side plus this side. So that means I'm going to have a 6d plus 2c plus 2b plus c. And you can keep your parentheses if you want. But when there's addition in the middle, those parentheses basically just fall off because at that point, again, you're just back to combining like terms. 7b plus 4d. And now, the hardest part of that guy would just be reading through and knowing perimeter and then knowing now you're back to a problem that looks exactly like the ones above it, except that I wrote it and it's not nicely printed. So 6d, I have 6 dogs. Then I have cats, I have bunny rabbits, cats, bunny rabbits, dogs. So more dogs. So those go together. So I have 2 cats, and I'll literally go down the line. 2 bunny rabbits, that's not 1. I have 1 cat. Like I said, you may want to put a 1 in front of that just to make sure you're staying the course correctly. Then I have 2 bunny rabbits. And then 7 bunny rabbits left. Part of the reason I do like the boxing in with the multiple colors too is if you have a long problem, it's very easy to like just miss a number. So if you don't want to box out, if you start left to right, so like the 6D, I would cross 6D out once I find, so 6D, and I go through and I find 4D. So 6 and 4 is 10D. And that's going to keep you from losing a number along the way, because when you're done, you should look and there would be a number not crossed out or not highlighted. So 2 cats, 1 cat, so that's 3 cats. And then last but not least, 2 bunny rabbits, 7 bunny rabbits, which is 9 bunny rabbits. And then that's your answer. But again, make sure you're following behind yourself, because these are easy. They're not complicated algebraically or mathematically, which is where, especially like I'll explain it in Math 2 and Math 3 if you have me again 100 times over. You're smart enough to do this. You're smart enough to get this right. You're so smart and so good at it that you mess up because you start taking for granted and sort of like you disengage from the problem. So just staying invested in the problem, making sure you're organized. So again, you don't have to draw your triangle, but your key would be knowing that, perimeter is adding all 3 of these together. So we would write it again. Do not do this in your head if I were you. So 6V plus 2 plus 6V plus 5 plus 3, oh boy, W minus 2. So violins, we have 6 violins, 6 violins. That's all my violins. And then the number 2, so a constant 2, constant 5. Make sure I make sure to box in the -2, so I just don't forget about that, the minus part, because having $2 and losing $2, every student always argues. They're like, oh, but that's so close. I just forgot the negative. But when I'm asking if you care whether you have $2 in your pocket or you lost $2 in the pocket, that conversation is very different. And most of us want what we want, like what it is. We want to know it. So 6V and 6V. So 12 violins. 2 plus 5 is 7. Minus 2. So these two guys basically cross each other out. So it's just going to be plus 5. And then last but not least, our 3W just comes down because there's nobody else in this conversation or problem that it would combine with at the moment. I'm going to skip the next one just for sake of time. If you want me to work it later, just holler and I will. So your next one is your start for distribution property. So these boxes are going to blow some of your minds just because it's different, but it's going to also help somebody who has had a problem with distribution in the past. So just bear with it, get through it. The 3 after that are not boxed like this. The idea, though, is so your 3 times 3A, so 3 times 3 is 9, and A just hangs on. And then 3 times 7 is 21. In the box, you're doing the same thing. And this box method is really helpful when we start multiplying binomials. So not just distributing 1 through, but so to practice it and not be aggravated by it is probably a really good skill. So 3 times 3 is 9A, so that goes in the box. 3 times 7 is 21. So your final answer is 9A plus 21. And either way is fine that you choose to do it, distribute or box method, both are allowed. The biggest call out for distribution, and this guy's pretty small, so it's not too hard, but to make sure, my suggestion, like on the second one, so 5 times 6G, which is going to be 30G. So I drew an arrow, I wrote some math. I draw an arrow, and then I write some math. And the reason, again, is that keeping yourself accountable. So when you look back, if your answer's not right and you're trying to figure out where you messed up, if you're missing an arrow, then you know where you messed up. If you just draw all the arrows and then go back and do your multiplication, which I've watched some people do, then the arrows don't help you through your work. The arrows are to help you stay focused on every number, not just to say you did it, if that makes sense. Now, this box is a little different. 5 times 6G is 30G. But 5 times what gave me -20? So obviously we have it up here. That's that -4. And that's just working outside to find the other part. So thinking about it full circle. So 5 times what gave me that negative 20? And again, your problem's already at the top for all of these examples, so you can pull your numbers from there if that makes sense. I pulled one more because, like I said, I know there's somebody that's like, oh, this is so weird and so not cool, but that's how it happens. So 9 times what is 27b? 9 times 3 is 27b. So that's our 3. And then 7 times 9, which is the second one. 9 times 7 is 63. Just a skill that sometimes, some of you have already learned it, I'm sure, but your multiples of 9, because you are going to have a calculator inactive test portion when you have your EOC at the end. But if you do your 9s on your hands, if you've ever done those before, so 9 times 3, pull down my third finger if I'm counting from left to right, is 20 because there's 2 on the left, and 7 because there's 7 fingers left on the right. So 9 times 5, if I pull down my fifth finger counting from the left, my thumb, that's 45. 9 times 7, so if I go 1, 2, 3, 4, 5, 6, 7, pull down my 7th finger, I have 6 fingers on the left, 3 on the right, so that's 63. Just a kind of a cheat hack to do your multiples of 9 if you need to. And then on to the good stuff. These are just your straightforward, for my algebra fans in the room, that you're going to answer on delta. But I wanted you to see them because there's a couple that I'm not sure how strong you're going to be. And again, it's depending on what your teacher prior to me has already covered. Very basic, like we just did. So 6 times m, 6m. Then 6 times a positive 6 is 36. So that's, again, your distribution property. And in class, I usually tell people, if you think of distribution as if the teacher brought a bag of candy and they started passing things out, and the students are the people in the parentheses. So that's 6. I'm passing out 6 Snickers to Matt, and then I'm going to pass out 6 Snickers to 6. If I happen to leave out 6, they're going to be upset, right? So you can't leave anybody out. So like the next one where you have 3 terms in your parentheses, you got to be really careful to make sure everybody gets candy. Or, again, you've been sitting in that class where everybody loses it. That one guy that got skipped, probably by accident. So same idea. So 3 times v is just 3v. 3 times 9, and that's a negative 9. So 3 times a negative 9w is going to be 27, but it's going to be a negative 27w, because a positive times a negative is a negative. And then 3 times 1 is 3. I am going to skip. Does anyone have any major pressing questions, or is this okay? Am I explaining it to the point where some of you understand what's going on? Or do I need to say anything differently for anybody? We still have a lot of problems, and I can change up the way I'm saying it. Crickets. So I'm assuming that I'm doing okay then. All right, I'm going to skip this one, because the only reason I really pulled it is at -5. So you make sure you're paying attention to the negative going all the way through. The next one, so 7x times a -3. So that's 7 times a -3 is a -21. And then the x just carries through with it. Yep, Hala, this is just polynomials. Yep. We're going to get into some equations starting probably tomorrow and Monday. So 7x times a -4x. So we're going to do 7 times a -4, which is going to be a -28. Now x times x. So x times x. That is not 2x. That is x squared. Because anything squared means that times itself. So x times x is x squared. I wish I could have pulled some of those out of your delta practice, but we couldn't get into any problems that were large enough without them getting into multiple variables multiplying each other. So that is why I pulled this one for now. So x times x is always x squared. So you deal with the numbers in the front, then the x in the back. Hopefully pretty simple. Our next guy. 3 times a -3. Make sure you say it to yourself in your head. 3 times a -3, negative. A positive times a negative is a negative, so -9. And then there's that imaginary 1 right here. So 3 times a -1x squared. It's going to give you a -3x squared. There's not an x on the outside, so we just use it as is, exactly as is. So the next one, now we have negatives and x's on the outside. Oh boy. So negative 3x times a negative 5x. That's negative 3 times negative 5. A negative times a negative is a positive. So we're going to have a positive 15. And then we have x times x, which is going to give me x squared, because there's two x's in the process. And then negative 3x times 3. Oop, I about messed up. But we're going to talk about it anyway. So plus a negative 9x. So plus a negative is the same thing as subtracting. So you could write it this way, or it could be 15x squared minus 9x. Both are correct. It would be one of those call-outs depending on what program, sort of your answer choices, how they're typed out, what teacher you had, all those kind of things. Which worksheet, which textbook, IXL versus Delta Math. And I only say that because since you're in a virtual format, there's no telling where you'll end up at some point. Khan Academy is one that a lot of people use too. We'll see some of it just because their practice is nice. All right, so negative 1 in front of here, 1, 1. Just to make sure I'm present and I'm paying attention to my problem. So I have a negative 1x squared times a positive 1x squared. Now, negative 1 times positive 1 is a negative 1. X squared, remember that's x times x, times x times x, because that's x squared again. That means there's 4 x's now, so it's going to be x to the 4th. You're basically adding your exponents. When you multiply through, the 2 plus 2 gives me that 4, and that's because it's 2 and 2, and that's where the 4 comes from. And then negative 1x squared times a negative 1x. So negative 1 times negative 1 is going to give me a positive 1. And then x squared times x. That's x times x times x by itself one time. So that's 1, 2, 3. So we're going to have x to the 3rd. And again, this is jumping a little like past some rules that we wanted to probably cover for some of us. So if you have questions, holler. But I wanted to make sure I showed it because it's definitely a thing in Delta, and I can't unfortunately go through and feed those out. So this one, it's just an x out front. So 1, if you want to get in the habit, it's a positive x. So our symbols are not going to change through. So x times negative 9x squared, or 1 times negative 9 is going to give me a negative 9. X times x squared is x times x squared. So that's 3 x's. Then x times a negative 5x. So that's 1 times negative 5. 1 times anything just gives us back what we had. X times x. So that's x times x. So that means it's going to be x squared. And then x, 1x, x times positive 9. The 1 leaves the 9. And we still have that x, so it just tags on to that 9. We got 8 more minutes. So I'm going to go ahead and hit these last 2 because ultimately they're like the big bully on campus that you don't actually know in the event for some of you. As they get bigger, don't panic. It is no different. And if you're using multiple colors and you're using your arrows the way I'm telling you to, and you're putting your 1s in front of your variables like I'm telling you to, which again, some of you are like, I don't need to do that. I can do it in my head. Trust me, the name of the game, especially working at home, you don't have anybody sitting around watching you. You're doing it by yourself. No one's looking at what you're doing. You want to make those small extra steps to make sure you don't mess up. Because again, you're super smart. You're totally capable of multiplying. You're totally capable of organization. You just have to decide to do it. Because these problems, again, are not super, super complex. It's the organizational process that most people have an issue with. All right, so we do have an x squared. So we did come hard on this one, but that's okay. So 8x squared times a negative 3x squared. So 8 times negative 3 is going to give me a negative 24. Then x squared, which is x times x squared, which is x times x. So that's going to be x to the 4th power. Then 8x squared times 10x. That's 8 times 10. 80. X squared times x. So that's x times x times x. So x squared times x is going to give me 3 x's. And then 8x squared times 10. So 8 times 10, again, is 80. X squared, there's nothing there, so it's just x squared. He just hangs on. All right, I'm going for the last one. Do you want me to pause for a minute? I'm going to pause for a minute and give you a second and see if you can get some of those numbers together. Logan, for these so far, no, but give me 1 second and I will finish this last one and then I will do a call out to what you're saying, to discussing, like simplifying further. There is a rule of putting it in standard form, which means highest exponent first, which probably I should have called out as we were going, but in the beginning the variables weren't the same. But now that we're in exponents, and again, that's kind of jumping the gun, but I will talk about it. So hopefully we'll do this last one real quick, and then I'll go back and show you the ones that we should probably change the order, and I'll show you where you can't simplify further. Because like terms like x to the fourth does not go with x to the third. You can't combine those. They have to have the same. So they're sort of like different last name, family last names. Though they look a lot alike, they're not the same. So one that I used to say would be, oh crap, hold on. Give me a second. I'll think of some names that I'm talking about. So 4 times negative 3 is negative 12. X times x squared. X times x squared means there's 3 x's, so x to the third. 4x times negative 5x, so 4 times negative 5, negative 20. X times x is x squared, because remember that's x times x, which means there's 2 x's hanging out there. And then 4x times a negative 6 is going to be a negative 24. And there's only that one x, so we're just going to put an x on the end, and that's it. So as far as like simplifying further, if we go back to your like combining like terms, so x to the third power is not the same as x to the second or x by itself. These are definitely 3 different family names. So Smith versus Smithfield, how they start, like they're pretty much the same. Like so an x is Smith, and then x to the third is Smithfield. They're not necessarily related, short of the Smith portion of their name, so they don't go together. So instead of like before they were different variables you were putting together, those with any variable above it, I mean with an exponent attached, that exponent changes the variable in as far as combining like terms would go. But thank you for asking that question, because there is another call out. You want to make sure that they're in highest to lowest exponent values for standard form. So x to the third, x to the second, x to the non-existent, which is an imaginary 1. So that's greatest to least. So that one's perfect. If we go back to our other one, again, 4, 3, 2 are 3 different family names, so we can't combine them. But 4, 3, 2 is in descending order, so that means that one's in standard form. It worked itself out. X to the fourth, x to the third. Again, fourth and third are different, so they can't be combined. And 4, 3 is descending, so that one's good to go as well. Negative 9x to the third, negative 5x squared, and then x, so 3, 2, 1. It is in descending order, and because none of them have the same variable, and I'm just repeating myself 100 times so it sticks in your head. If none of them have the same variable, exponent on the variable, then they cannot be combined. But 3, 2, 1, so we're good there. X squared and x, those are not the same. Again, 2 different, that's a Smith and Smithfield kind of conversation. 2, the non-existent 1 means they are descending. That's perfect. Now, if we're looking at this one, though, teacher, oops, getting excited, just focusing on one thing at a time. There's no variable at all, and then there's an x squared. So not every worksheet, not every program, but most, and most teachers as well, want it in descending order, which is standard form. So standard form, is descending order, so from largest to smallest exponent. And then your constant is usually always in the back. And you'll learn about that more when we start getting into quadratics. In standard form, it's usually at the end because there's not a variable. So it does have the lowest exponent. So it's going to be negative 3x squared. Be careful because that minus matters. And so in this case, it's green, so it's a little harder to ignore. But when it's all black, a lot of people will get rid of that when it's just pencil or pen or ink. And then minus 9. So this is the way, the correct, like the most correct way that this answer could be written. And again, x squared versus no variable means you can't combine like terms. Looking at this guy again, we have x to the imaginary 1, because if there's nothing there, there's an imaginary 1 exponent. And then 2, so 1, 2 means it's not in descending, it's in ascending, so it's getting bigger as it goes, which is the wrong order. We always want the largest one first, so negative 28x squared. Again, call out to your minus here, make sure you stick it when you move it to the front. And then negative 21x goes in the back. So 2, imaginary 1, that's in descending order. And when your variables don't match the order, there is no quote-unquote standard form. Like there's not a variable that necessarily goes in the front. There's not a variable that necessarily goes in the back. It's whatever makes sense to you. I'm a big fan of putting the number with no variable at the end just because of all the different types of equations and things further down the line in our math careers. The constant is usually at the end. That's where we like it. It's easier to see instead of putting it in the middle and making it all out of order and whack compared to other standard form equations. But again, if the variables are not the same, it doesn't matter. It can be in any order that you would like. All right, so that was combining like terms and distribution, as you will see on Delta Math.